What's going on, everyone? Steven here, back with a new video. Today I'm going to be talking about NoClip. This is per the request of a number of my viewers over time, so I figured now I would just go ahead and do one of these. This is going to be a more advanced NoClip, but I'm going to discuss the topic of NoClip, and then we're going to dig in and see how it all works in this particular game. So what is NoClip? A no-clip hack is a type of hack that allows you to walk through walls, or allows your camera to go through walls. Alright? Excuse me. So, I like to think of it more as a no-collision hack. So your player object, or whatever object, is not colliding with anything else in the environment. But you can go, I'll leave in the description a link where you can read about clipping and the origin of NoClip, things like that. But anyway, suffice it to say, it's called a NoClip hack. That's what we're going to do here. So as you can see, the player collides with the wall here, right? But if we look, she's not colliding completely with that one piece of the rock that's jutting out there, and that's just because of where they have the boundary set for this wall, right? So one thing you got to think about is the player and the camera. So in third person mode, like we are right now, what we're looking at there is the player avatar. Alright, that thing is an object in this game world. It has its own XYZ coordinates and it moves around. We're following it with a camera. This camera also has its own XYZ coordinates in the world, as well as pitch, which is this up and down movement, and yaw, which is this left and right movement. So when you do a NoClip, there are a couple of ways that you can go about it. First, you can do like a fly cam, which is where you decouple the camera from the player avatar, and then we could move this camera around anywhere we want in the environment. Generally, there is no collision. I said generally weird there. I wanted to say another word, but I didn't quite get out with it properly. Generally, the camera does not have collision tied to it. Okay? It's all in relation to that player avatar. Alright, so unless you're in first person mode, and then that's a different thing, where the game can sometimes have just the camera with whatever you see in your HUD. You know, you might see a hand or whatever. And then the camera might have collision tied to it. So, yeah, it depends on what you want to do. The type of collision or no-clip that I'm going to show you how to do is the traditional kind of no-clip with the camera. We're going to do the camera, and then if you go get this game, Girl X Mushrooms, it's a really cheap, low-budget type game. Then you can find the player to find the player's XYZ coordinates, and then see about doing no-clip with like the player avatar. The problem that you'll have sometimes with the player avatar is you'll find the thing that you want to, that will make you not collide with walls, but it also means you don't collide with the ground, so you fall through the ground. And that's its own topic and thing to sort out. Alright. Finally, there's the idea of no-clip in 3D games like this versus no-clip in 2D games. Alright, so something like Cuphead, a 2D game, collision is typically easier to find in that. But yeah. So anyway, to find this thing that makes you stop whenever you collide with an object that's got collision that you shouldn't be able to walk through, so you collide with it, there are a number of mechanisms that are used. One of them could be Boolean values. So, is the player colliding with an object right now? No. Boom. Is the player colliding with an object? Yes. Now that the player is colliding with an object, don't let the player pass through the object, right? So you could try scanning for that Boolean value, 0 or 1. Or it could be some other value. It could be 0 or 1 as a float. It could be any other value. So basically the type of scan that you would do is you stand up against the thing that you're colliding with. Alright? You try to do a new scan from that, then you move away from it to where you're not colliding anymore. Scan for a changed value, get back into it, scan for a changed value, and do like that. You know what I mean? Just constantly. And then you can do unchanged scans while you're up against it or not up against it, whatever. That's one way. The other way is to find like your XYZ coordinates of the player, all right, and you look at the instructions that access the address. Okay? So if we found this player's XYZ coordinates, usually with each of them, there will be maybe an instruction that once you start colliding with something in the world, that instruction will start running, and then you move off and you'll see that instruction stop. That instruction might be reading a value or it might be writing a value. So you might need to do something with that instruction. Or you'll see other instructions that stop running when you're colliding and then they start running again when you're not colliding, and you can dig into those instructions. That's kind of what we're going to be doing with the camera. So here I have a script where I've already found the camera rotation. So I'm not worried about the camera XYZ coordinates where the camera is placed in the world, although there would probably be some things related to that. But as you can see here in the cheat table, I have pitch, yaw, and zoom. Alright, so with a camera, again, pitch is the up and down movement. Yaw is this movement, left and right. Zoom is zoom. Right? Zoom in, zoom out. Okay? So when you want to do a NoClip hack, you kind of want to look at the behavior that you're seeing on the screen, like what's happening. Okay? Like here you can move around, you're not colliding. Boom, now I'm colliding with something. I can't move. Alright? Same thing with the camera. Right now I'm able to freely move and zoom. What happens whenever I back into a wall that the player shouldn't be able to pass through, nor the camera? Alright. The character moves closer to the camera. Right? It limits the camera's zoom. Basically, that's the behavior we're seeing. Zoom is being affected. Alright? So, one thing we could try to do is, now that we know that when the camera is colliding with this wall, the camera stops zooming, which value do you think that's affecting? Zoom, right? Therefore, we should be able to right-click on zoom here and say find out what accesses this address. Okay? So let's watch those instructions that are running right now. Nothing's changing. Nothing is changing. So I've already dug through these and found that it's not any of these. There may be something, like if we went into one of these, let's say this one that writes. Okay. Maybe something up farther here has something to do with, you know, if the camera's colliding with an object, then put this value of zoom in here, and then it makes it to this right, and it'll just continuously write that until the condition is changed, right? This is where it really helps you to know assembly, so you can kind of read up through stuff and get a good idea of what on earth is happening. But since I've already dug through these, I know that none of these, to the extent that I dug through them, modified this value while we're colliding. And we see more evidence of that when here in the game, alright, watch the zoom value here of 25. When I zoom in, watch what happens. Alright, we're at 1.5 now, 15. Now we're at 25. Let me back into this wall and watch what happens with that value. Nothing happens with that value. What does that mean? Well, since we know it's none of those other instructions, because I told you, we can assume that maybe the value of zoom is being written and changed and read from somewhere else, which maybe we could search for that, right? So we know that right now with the camera zoomed out this far from the player, it's a float of 25. That's that value. So presumably when the camera is zoomed out, right, we are at a value of 25. And then as we start to get into a wall and it collides, what's going to happen with that zoom value? It should be increasing, because remember when we zoom in, or I'm sorry, decreasing. So going from 25 down to something. Because as we zoom in, that value goes to 15. As we zoom out, it goes to 25, right? So let's try scanning for a value like that to see if it's elsewhere. Let's go float. Let's search for a value of 25. First scan. Okay, now let's get into the wall here and let's search for an decreased, not increased. Let's search for a decreased value, all right, because we know the camera's getting closer to the player. So I have hotkeys set up. I just searched for a decreased value. Now I'm not going to do changed and unchanged, because as you'll see, sometimes there are values with the camera that will be changing continuously, and it may be such a minuscule amount that you can't see it on the screen, but the value will be changing over here. I'm also going to toggle this simple values only, because with these float values related to camera, a lot of times these values here with the E are irrelevant to what we want. Alright, so simple values with each scan means that those ones that have E's will be filtered out as well. Alright, so let's move back out and we can search for increased. Come on. Increased, there we go. Get back into the wall, decreased. Let's move a little closer to the wall, decreased again. Let's move away from the wall and increased. Move away farther, increased. Alright, let's look over here in our results. Okay, remember we thought 25, a float of 25 should be what we see, right? So here we see these two values, 24.9. That's very close to 25. Let's copy both of these values. Alright, now look here. The zoom here that we know is at this memory address, 19C5C6. Look at these two values, 19C5C6. These values are in the same structure as these pitch, yaw, and zoom. That's a really good sign for us. So let's do this. Let's toggle these values and see what happens whenever we get into a wall. Alright. You see this funky behavior? The camera's still being limited, but we're seeing this like jumpy zoom in, zoom out. That's good. Oh, and whenever we moved away from the wall, you saw that. Let's try to change one of these and see what happens. Alright. Let's untoggle that one. If we change this one to 6, nothing happens. We don't care about this one for what we're doing because that's obviously not it. We know that this value controls zoom. We just watched it zoom, you know? So once we get into a wall here, watch that value. Look at that. That's changing. That's doing what we expect. So now, let's right click on this and say find out what accesses this address. Look at all these instructions. Now watch those instructions. Those are all running. Now when I collide with a wall, let's see what we get. Look at that. This instruction has stopped. These are now writing and reading. This is an instruction that reads. Okay. This one is an instruction that writes, and so is this one. So if that bottom one is an instruction that's writing to that zoom while we're colliding, what happens if we get rid of that one? So in other words, when we're colliding, don't write anything there. Just keep using the one you would normally do. Let's show disassembler. Let's NOP this instruction. And look at that. We're now moving inside the wall. We are not clipping with the wall. Cool, huh? So this would be NoClip for the camera. And sometimes it's more convenient for you to do this with the camera instead of the player, because especially with certain like anti-cheat things, it won't detect clipping of the camera, it'll detect clipping of the player. So if you're in a third-person mode, you could do NoClip of the camera and, you know, do stuff like this. Anyway, so now that we've done that, let me stop this. I'm going to close that, and now I'm going to keep that instruction NOPed. And now I'm going to enable the script that I have here, alright, which is going to enable mono symbols so that I can run this custom zoom script I made, which gets rid of the zoom limitation, so I can zoom as far in and out as I want. I'll enable that. Alright, now if I come into the wall here and I zoom out, I can zoom as far out and into here as I want. Alright, I'm jumping in here really quickly because I forgot to go down a little bit of a path that I wanted to just to finish things up here. So really quick, what I did was, since that zoom collision value was so close in memory to this structure that I had already found, I just went ahead and added that as another address to have here so that I can just quickly find it again the next time I start into the game. So that's done. Okay, the next thing is, if I want to create a script to just go ahead and get rid of that collision, then what I would do is, here in Memory Viewer, okay, see these values here? Since this is a mono game, if I didn't have the mono features activated, you would see this. Yep. There we go. You would see these numbers, and no matter what you did, you would just see these addresses. Well, these addresses are going to change in memory the next time you start the game. So if you don't see the module plus offset, then you go to view and make sure you have show symbols and then show module addresses for other games selected. If you still see just those addresses there, then what you need to do is enable the mono features so that you can see those. To do that in a script so that someone wouldn't have to come into mono and activate features, you can create a script that when you enable it, it will do it through Lua. So this is basically the equivalent of you clicking mono and clicking activate mono features. So I'll do that first generally, and then what you can do is create scripts that target these like method names plus offset kind of thing. Okay? So that's how that works, and that's what we're going to do here. So this here, this was the instruction that we NOPed to get rid of that collision value being written to when we're colliding. So what I like to do, I'll just go to Tools, Auto Assemble, Template AOB Injection. We're not going to be injecting anything because we know what we want to do here. We want to NOP everything. So we can get rid of all this. We'll keep the enable, and we'll keep the disable. And then what we can do is, here is where we're injecting. See how this has this? We don't want that, we want this. So we'll do V third person camera camera movement. Alright, we'll put that in quotes like that, and then we can specify the offset CA5. Alright, so now that we have that, this is the bytes that will be declared when you disable, so this will write the original value back to there. Alright, I'm going to say this is zoom collision, just so I'm keeping a little note of what's going on here. And then we'll copy this, paste it here, and we'll just write NOPS the whole way. Alright, get rid of these two things. And now we can assign to current cheat table, and we'll call this no cam zoom collision. And then I will bundle it here under these other scripts. So now what I can do is come in here, and if the mono features weren't enabled, I could toggle this script first to enable the mono symbols, which would then allow other scripts to target like this. And then we can toggle this script. And there we see there are the NOPs, and we come in here in the game, and again we are not colliding with the wall. And let's stay with the collision there. Let's toggle the script, and there we go. Now we're colliding again. So there you go. That's how you create the script and all that. And now back to the rest of the video as it originally was. No limitations insofar as keeping zoomed into the player. So it's essentially the same process for the player, but this is a more complex example, I think. Usually you can find that Boolean value, like is colliding or not, and start from there and get pretty lucky. Or usually there will be something related to the one value that you can find initially, right? So anyway, that's kind of the basics of NoClip. I hope you found this helpful. Like I said, got a link or maybe two in the description below so you can read a little more into it. But give me a thumbs up if you enjoyed the video. Don't forget to subscribe, and I'll see you all in the next one. Take care.